Across the United States, wildlife populations are growing out of control in many regions. Invasive species are thriving, native predators are disappearing, and balance is breaking fast. White-tailed deer overgraze forests, feral hogs destroy farmland, and coyotes encroach into suburbs. Without natural checks, animals are multiplying rapidly, damaging ecosystems and pushing species toward collapse. And that leads to one of the most controversial ideas in modern science. What if we didn't remove predators, but designed a better one? Could scientists engineer a super predator, a biologically enhanced species, to help control wildlife? A predator smarter, faster, and more adaptable than anything nature created before. It sounds like science fiction, but it's a discussion already happening in labs. And the implications are both thrilling and terrifying. Let's start with what we mean by superpredator. This isn't a monster or an unstoppable killing machine. It's a genetically engineered animal created to restore ecological balance. Imagine a predator immune to disease, resistant to climate change, and finely tuned. It wouldn't be wild, it would be programmed to target specific species in specific areas. Its genes could be edited using tools like CRISPR, allowing precise biological upgrades. That might include enhanced night vision, better endurance, or sharper tracking instincts. Some scientists believe such predators could replace toxic pesticides and mass hunting programs. Instead of humans culling deer or poisoning rodents, a lab-grown predator does the job. Theoretically, this predator could be designed to self-regulate. Its population could be capped through programmed sterility or seasonal reproduction limits. It could be encoded to avoid humans, livestock, and endangered species entirely. It would act as a precision tool, a biological solution for overpopulation. But is this even possible with today's science? Thanks to gene editing breakthroughs, the answer is technically yes. We've already created glow-in-the-dark mice, disease-resistant pigs, and hornless cattle. Synthetic biology is advancing faster than governments can regulate or understand it. Insects have been modified to collapse mosquito populations in Florida and Brazil. Genetically altered fish grow faster and eat less food in aquaculture labs. And gene drives, techniques that pass traits to all offspring, are already being tested. So the technology exists. The real question is, should we use it on predators? Supporters argue it could revolutionize conservation. Engineered predators could be deployed in ecosystems damaged by invasive species. They could help control deer in the northeast, hogs in the south, or rabbits in the west. They might reduce car crashes caused by wildlife and slow the spread of Lyme disease. They could help endangered plants and small animals by thinning out dominant herbivores. And unlike bullets or poison, a superpredator could adapt and endure over time. But opponents warn the risks are enormous, and possibly irreversible. First, no matter how precise we program them, biology is never fully controllable. A superpredator might switch targets, reproduce unpredictably, or spread into new ecosystems. What begins as a solution could quickly become an invasive threat. Second, once released, it would be nearly impossible to recall or contain. Unlike a tool or drug, you can't unrelease a living organism into the wild. And if it mutates or adapts, the consequences could spiral out of control. There's also the ethical dilemma. Would we be creating animals for the sole purpose of killing others? Would they suffer? Would they feel pain? Would they be exploited for ecosystem labor? Where do we draw the line between nature's predator and engineered pest control? And then there's the legal question. Who owns a superpredator? The lab that created it? The government that deploys it? What happens if it crosses state borders or kills livestock or pets? Would the public accept a predator they can't hunt, track, or remove? The debate becomes not just ecological, but political, legal, and moral. Some scientists suggest starting small, with engineered microbes that kill invasive plants. Others propose releasing sterile predators that only last for one generation. Or tagging them with fail-safe genes that deactivate under certain environmental conditions. There are even proposals for lab-created smart predators guided by remote AI. But each step forward opens a new set of complex questions. Are we fixing nature, or playing God with the food chain? Will future conservation be about understanding ecosystems, or editing them? Supporters say we already altered nature by destroying predators and fragmenting habitats. This, they argue, is just taking responsibility and using science to restore balance. Opponents say it's dangerous to believe we can outsmart millions of years of evolution. Especially when a single mistake could wipe out species or collapse entire ecosystems. For now, the superpredator remains theoretical, discussed in white papers, ethics panels, and sci-fi novels. But with ecological collapse accelerating, the pressure to try radical solutions is growing. And what seems impossible today might be policy within the next decade. So, could scientists engineer a superpredator to control US wildlife? Yes, they could. The real question is, what happens if they do?